Yeah, today's topic is fractions. Same introduction to fractions part 2. So what is this actually? So fractions are nothing but a piece from a whole part. Whole or its whole. Just whole, okay? Complete figure. From complete figure, you are taking just a piece. So that is denoted as fractions. So example. See, when you're, I'll just explain by using diagrams first, okay? Okay, let's take an example. First example, I'm taking a square here, okay? So you need to, if you want to make pieces, or else, for example, 8 pieces or 3 pieces or any number of pieces, each piece should have same quantity. If you take cake, okay, cake, so you're going to give small pieces to your friends, right? You are going to distribute each and every piece to your friends, not complete this one cake to one person. You won't distribute in that way, right? So if you want to make some pieces, 1 2 3 pieces, 1 2 3. So how many pieces I have done? 9 pieces. So 9 equal parts I have done to one diagram, okay? So if I take one piece, another piece, one more piece, and one more piece, okay? How many I have selected? 4 I have selected from out of, imagine it is a cake and I made it into 9 pieces, and from that 9 pieces I have given 4 pieces to my friends, okay? So how to represent this? I cannot say one piece. Yeah, if you say even one piece, 4 pieces, okay? Let's take 4 free pieces from 9 pieces, okay? Given to friends, okay? Imagine it is a cake, say a birthday, okay? So you have done 9 pieces and you have given 4 pieces to your from 4 pieces to your friends. How many pieces you have given means you can say 4 pieces. See, it's an English word, right? I want how to represent that mathematically. Representing mathematically, how you are going to do? Mathematically. Yeah, how to represent mathematically? Now, so to one cake, how many pieces total, completely how many pieces you have done, that you need to write in a denominator, and how many you have selected, that you need to write in a numerator. So given to given to friends. Next, remaining how many you have? 1 2 3 4 5. 5 by 9 left in. Where you are going to keep this? Fridge, right? The fridge, or obviously your family members will eat this. So completely 4 by 9 plus 5 by 9 together gives one cake, right? Complete cake. Let's check whether it is true or not. 9 9. 4 plus 9, sorry, 4 plus 5 is equals to 9 by 9. So which is equals to 1 cake. Clear? Understood? Now, this is introduction to fractions. Actually, what is fraction? A fraction is nothing but a piece from a whole part. Now, let's start types of fractions, okay? Types of fractions. First type is God. First type is proper fraction. What are these proper fractions actually? Okay, when you take a fraction, how you are going to represent? Numerator by denominator, right? Yes or not? Now, what is the proper fraction formula? Is nothing but numerator is always less than denominator. Okay, shortcut for numerator is n smaller, denominator is d smaller. Okay, now example, 5 5 by 4, no, not 5 by 5 by 14, 3 by 7, 8 by 19, 7 by 10, etc. So if you observe all this, how we are going to check whether it is proper fraction or improper fraction? Means numerator value is less than denominator or not. 5 is less than 14, yes, so it is proper. 3 is less than 7, yes, it is also proper. 8 is less than 19, yes, it is also proper. 7 is less than 10, yes, it is also a proper fraction. So all these proper fractions lies between, note, all proper fractions lies between 0 to 1. Okay, if it is a positive one, it lies between 0 to 1. If it is negative one, lies between, if it is positive. Negative mean, if it is negative, it lies between -1 to 0. Okay, if it is negative. Clear? Now if you won't understand what is this, I can explain you by taking this. Okay, 5 divided by 14. Okay, now you need to divide 5 with a 14. Now how we are going to do? Denominator, whatever is there in a denominator, that is a divisor, right? 14, you are dividing to whom? 5. 14 ones are 14 it will be, right? It's not a what point, so that you can add 0 here, decimal points. Now 14 ones are 14, 14 twos are how much? 8, 2, 14 threes are 3 fours are 12, 3 ones are 3 plus 1 4, 42. So like we can take this, 4 threes are 12, or else 3 fours are 12, 3 ones are 3 plus 1 4, so 3, 42. What is our remainder? 8. Again, because you kept a decimal point over here, you can take even 0 also. Now 14, 7, so let's take 7, so now 6, 84, so 6, it doesn't work. 5 4s are 20, 70, so we can take this. Now if you observe, still the division continues, but after decimal point, you can decide what is this value actually. 0.35, it's nothing but 0.35, it lies between. So if you take this scale here, 0 to 1, 0.3 means 0.1, 2, 3, so this is 0.3. So whatever proper fractions are there, it lies between only this gap. If it is a positive one, it lies between 0 and 1. If it is negative one, it lies between 0 plus 1 minus 1 plus 2 minus 2 plus 3 minus 3. If it is a number line, so always proper fractions lies between -1 to 1. Clear? Understood? Second type of fractions are improper fraction. What are these? What is the definition of improper fractions? Okay, fractions whose numerator value or else is greater than denominator. So if the numerator value is greater than the denominator, then it is called as improper. Okay, improper fractions. So what are the examples? 3 by 2, 4 by 3, 7 by 2, 10 by 3, like this. Okay, if you observe the proper fractions example, numerator value is less than the denominator. So because of this, all the proper fractions lies between -1 to +1. If it is a negative proper fraction, then it lies between 0 to -1. If it is a positive one, it lies between 0 to 1. That's it. So these are proper fractions. What are the improper fractions? It lies between more than it lies between plus 1 to so on, here this side, and here this side improper, negative improper, improper, this is also improper. Okay, if it is a proper fraction, positive one, it lies between 0 to 1. If it is a proper fraction of negative 1, it lies between 0 to minus 1. And if it is an improper fraction, it lies between from here 1 to so on, and here minus 1 to so on. These are improper. Okay, now let's check. Okay, don't copy all this, just listen. Okay, if you want to copy up to here. Next, so this is the definition of improper fraction. Let's see what is this actually. 3 divided, first example, 3 divided by 2 means you are dividing 3 with a 2. 2 ones are 2, remainder 1, 0.0, 2 5s are no. So this is 1.5 means greater than 5, greater than 1 or not. So now next 4 by 3, dividing 4 with a 3 ones are 3, 1.0, 3 3s are 9. So if you want do like this, you will get answer, but I need only after decimal point what will be the value, 1.3 something. So 1.3 is nothing but greater than 1 or not. That's it. Now how to represent this? These are called improper fractions. Okay, third type is mixed fraction. So what is mixed fraction? Improper fractions can be converted into mixed fraction. So take an example. Okay, you can take any example. I just want to take 17 by 2. So what is the 17 by 2? Proper fraction or improper fraction? Numerator value is greater than denominator. 17 is greater than 2. So therefore it is a improper fraction. So improper fraction, only improper fractions can be converted into mixed fraction. So how to convert it into mixed fraction? Mixed fraction of 17 by 2 is simply just do the division. Okay, so 17 you are dividing with the 2. So 2 8s are 16, 1. So this is remainder. This is divisor. This is quotient. Right? Now this is dividend. Of course this one you know, right? So if you want to know what is mixed fraction, you should know what are the what called parts, which is called as divisor, which is called as quotient, which is called as remainder. So 17 by 2 is a improper fraction. This is converted into whatever denominator is there, the same denominator you need to write. 2 8s are, right? Quotient you need to write here, quotient. 2 8s are 16. In the place of numerator you need to write remainder. So 2 8s are 16 plus 1 17. 17 by 2 is the answer. Now let's check a few more examples over here. Okay, like 37 by 5. Okay, just do the division here. 37 with a 5. 5 7s are 35. What is the remainder? 2. So how to convert this? 5, whatever denominator is the same denominator you will get. 7 5 7s are quotient. 5 7s are 35. Remainder on the top. So 7 2 by 5 is the mixed fraction. of 37 by 5. Now 17 by 3 if you take, okay, another example. You are dividing 3 with the, you are dividing 17 with a 3. Now what is answer? 3 6 are 18. You cannot take, so 3 5 are 15. So 2 is the remainder. So how to write 17 by 3 as mixed fraction? 3 5 are 15, remainder on the top. 5 2 by 3 is the mixed fraction. Clear? Understood? The fourth type is like fractions. Fractions whose the fractions or else group of fractions whose denominators are same. Example, 5 by 3, 7 by 3, minus 13 by 3, 4 by 3, 11 by 3, etc. So if you observe this set of a group of fractions, all the denominators are here 3, therefore are like fractions. Okay, now same another example, 7 by 14, 13 by 14, 5 by 14, 17 by 14, minus 3 by 14. These are all like fractions. Why? Because 1 2 3 4 5, in all 5 fractions their denominator is same. What is that? 14. So these are also like fractions. What are unlike fractions then? Unlike fractions are nothing but 3 by 4, 7 by 3, 19 by 14, 16 by 3, 4 by 5. All these are, see, these are the group of 5 group of fractions. They are not like fractions. Only 2 are like. So these are unlike fractions. Unlike fractions except these 2. See, these 2 are like fractions. The remaining are unlike fractions. Simply, like fractions opposite is unlike fraction. Clear? So whose denominators are not same. If the denominators are same in all the fractions, then they are called like fractions. Clear?